kind of reminds me of some conversations I used to have with my grandfather about weird stuff. You know, the stuff that you get wrong before you, I don't know, it really enhances you. The stupid questions and then the stupid answers. One time we were talking about land mass that was moving apart. Some article he read in the paper, and then he told me that. Then I asked, why couldn't we attach like ropes? I don't know why. It's to either side of the landmass to stop it from separating. And he laughed and said that that probably wouldn't work. But another one was about water storage, which was quite interesting. It sounds so stupid back in the day. I think there was a lot to do about the ice caps melting at the time, and I found this quite a strange thing to say, but overall, could you imagine if you could convert the salt water into fresh water and then ship it to the poles? And that would sound like a really silly thing to do, wouldn't it? But you are essentially moving water, which it's going to take a long time to melt here than what it is here. I think it was rising sea levels. We went to some coast somewhere, and they were talking about parts in 50 years. This part won't be here anymore, and stuff like that, due to the erosion and everything else. So a part that we were standing on 50 years later, it's not going to be there. Well, I think I was around 8 at the time. So that's getting close to 50-year margin, give or take. So whether that part is now under the ocean or not, that remains to be seen. It didn't exactly put a flag down where it was. But again, this was because of rising sea levels. But at the same time, it's not that impossible to be able to deal with rising sea levels. And by and large, Earth is a water world, believe it or not. And to think about it, if there's no life on the planet, no nature, this planet would look very different. We often see it as we're born into it, and then we begin to focus, and our awareness comes as a species, but we don't ever look back. So if we were to strip the earth of life, nature and everything else, how much more water is that? And then let's say if there's an event that causes the caps to melt naturally or otherwise. Factor in volcanoes as well. You know, you could understand that the moon perhaps was closer, and by being so, then was there more friction? Was the core bigger? If the core has been cooling down, and if it is based on a moon, again, this would be something that would need to be tested. But if you had an object that was orbiting an object, and if it was closer, does this make the core bigger, hotter? More friction, more stretching and squeezing, then there's more stretching and squeezing, therefore there's more to melt. More to melt on the inside. Well, we could understand that that would make a lot more water and perhaps a lot more atmosphere. Then if it is warmer and more atmosphere, then you would understand that life forms would be pretty big if they did rise up on the planet, but they would need a platform. So we could say it was mainly ocean water and small skims of land mass. Underground, or it should be underwater volcanoes that begin to rise up. But then what, the moon moves away? Is that then less heat? Less heat that there is? Then surely that is going to have an impact on volcanoes. Volcanoes are going to erupt, less internal heat plus from the star, isn't that going to create ice? Things are going to begin to freeze a bit more. Less atmosphere. Then there's less sunlight to catch hold of that. Yeah, we could think about it in a way. Interesting. The more puffier the atmosphere, it's basically saying I'm bigger radiation. Then there's more to absorb from the star. Then if I'm smaller, there's got to be a less for me to grab from the star. And then internal has a consequence external. So if you've got more internal heat, more heat, less ice. Less ice from the friction, and again, less ice, puffier atmosphere due to the evaporation because it's more hotter. So the more hotter it is on Earth, the more atmosphere you're likely to have. That's why water is so beautiful, really, and not just water itself, but its composition of salt water and fresh water. This balance is, it's brilliant, just the way it sweats. And you can drink this sweat, and you can sweat back into the ice. It's just a beautiful system, to be honest. But the more you think about that, then nature takes hold. With there being more ice, isn't this going to drop the ocean level? Less heat internally. Yeah. That's going to change the composition quite a bit. And then trees come. Let's say nature becomes quite widespread. And again, that's going to change the environment drastically. How so? It's going to protect the water from being evaporated. Each time the layers, the tree or the forests die, it's building up, taking nutrients, and it's also taking particles from the star. Although it seems invisible and it seems like massless objects, but I'm pretty sure the star is pumping out certain amounts of in its burst, and it triggers the northern lights. There must be a sprinkling of something coming from this. And trees seem to make quite do with it, don't they? And again, they're rising the landmass, volcanoes rising the landmass, and then you see how a water world turns into a percentage of landmass. And we hang in that balance. And that then led to the nature's behavior led to, and also the planet's behavior led to nature. Perhaps the moon's behavior led to, more landmass to happen. I don't know, to knock this out, the moon out all of a sudden, what happens to the Earth? If there's no more stretching and squeezing at close proximity, or however else the moon is orbiting, it's pulling the crust. And if it is pulling the crust, then this is going to influence large bodies of water. Especially, it depends on how it orbits and how close it orbits, the more of the crust is going to be pulled. That's an interesting thing. Very interesting. And this stretching and squeezing is going to allow the core to remain hotter for longer. We don't see it on many other planets. We see it on Mars, and then we've got to figure out, how did Mars pop like a spot? And then you get two clues that are orbiting around Mars, Phobos and Deimos, and then a load of shrapnel across Mars's surface, and the shrapnel between Jupiter and Mars. That's a very interesting thing, isn't it? And again, if you've got a puffier atmosphere, are you less likely to leach it? I don't know, it's an interesting one. Atmosphere as a gas. If a meteorite hits the planet, are you going to lose less atmospheric gases if you have a puffy atmosphere? But if you have an atmosphere that's collapsed down, so you could take Pluto further away from the star, it's vulnerable because its atmosphere has collapsed on the surface, and anything that hits that meteorite, it's going to knock off atmosphere. And we would call this ice. If it had water, it would have more ice on it. No atmosphere. The atmosphere is the ice compact down. And when a meteorite hits it, it's vulnerable. It's going to lose more of its atmosphere, so that when it comes to puff up again, it's going to have less to do so. Closer to the star it goes. If it's hit by a meteorite, I think it's going to lose more of its next layer, which would be what its body, whatever it's made of. So if we say rock, I'm just going to assume it's going to knock more rock layers off. Yeah, sure, the atmosphere is more likely to pull this stuff back in, but without an atmosphere, I think it gets hit and off it goes. So perhaps Pluto had more of an atmosphere at one point, but when it collapses down too much and a meteorite hits into ice, ice would be then the next crust. And that crust is brittle to chip away bit by bit. I don't know, either or. So if the moon doesn't have an atmosphere and no way of heating, because in order for you to have a puffy atmosphere, you need a level of heat. And then you're going to need some gases that are no longer as hard as what they are to puff up. But you're going to need a heat source. And the moon orbiting around the planet has got a dark side. So you could see it if it did have enough ice on it and it had a big enough gravity, then you would see the moon in a very different way. It'd puff up when it was closer to the star, and then when it orbited around the back of the planet into the dark side, it would then collapse down the atmosphere and then it would puff up if it was getting its heat only from, let's say, the star. That's an interesting thing. That would be freaky, wouldn't it? That would be a really weird thing to see. Puffing up, collapsing down, puffing up, collapsing down. And if it did ever have an atmosphere on it, especially water or remnants of it, then with the amount of impact that happened, it would be more vulnerable to lose its atmosphere if it was on the dark side and being shaded by the Earth. Because the atmosphere would collapse down, and anything that hits it in that moment, it's going to chip away bit by bit. That's a very interesting thing, and it's almost like the moon protects the Earth one way, and then the Earth protects the moon the other. Crikey, that is interesting, isn't it? It's never one way. Dark side of the moon is very potted. Again, if it had an atmosphere on the dark side of the moon, and it was in Earth's shadow at the time, then the atmosphere would have collapsed down. You can see how meteorites, bit by bit, micro or otherwise, are going to chip away at that, because it's going to knock those remnants out. If it's more potted behind the moon, then you never know, the moon could have been an ice body, and all of those impacts that hit it on the dark side could have thrown those fragments of moisture into the Earth, and essentially Earth could have got 2 planets worth of water just by this process of puffing up, puffing down, puffing up, puffing down. When it was more vulnerable and the atmosphere puffed down, it can knock this into the Earth. A weird way to think about it, but still. If the star is here, let's say, Earth is going to cast a shadow. And much like Pluto when it's too far away or it's cold. So does it really have an internal heat source? Who knows? And then the atmosphere collapses down. And then when it starts to reach here, the moon, it's going to be hitting with the star, so the atmosphere would then puff up, collapse down, puff up, collapse down. When it's here, if a meteorite hits this way, it's going to throw the shrapnel into Earth's puffier. It's going to be able to more grab that moisture. And you could say that Earth got 2 lots of atmosphere, 2 lots of water. It's almost how it almost appears, doesn't it? So could our moon have been like a Europa? Interesting, really. You would only know if the moon was hollowed out and it had caves in it, cave systems, which would be fascinating, because then it would lead me to understand personally, and for me, I would say that there would have been water on that. Maybe not water as we know it, but at least some sort of puffing out, drop down, puffing out, drop down. I think it's got a thin layer of oxygen on it. But again, if this is in the shadow of Earth, we should see that collapse more down and puff up and collapse down and puff up and collapse down, because it needs heat. And without heat, how does that gas become gassy? Well, you would say it was in the sun. Yes, but it's not always in the sun. It's also in the dark. It's a very weird way to think about it. So we look at the Earth, and if we can see the dark side and we could light it up, is one side of the Earth in the dark side? Is it slightly more collapsed downwards, and the outer side is more puffed out towards the star? Interesting, but again, it regulates around the atmosphere, so that could be slightly different because it's half and half. But if the whole thing is dark, well, that's going to have a very different effect on its behavior. Yeah, it's almost like that. And I often wonder whether planets get two lots of atmosphere. And could have Mars got an extra atmosphere if the Phobos and Deimos, and then you've got the, is it called the Kuiper Belt between Jupiter and Mars? If all of that debris, and it's what, made up of, some of it is heavy and more denser materials, rock and stuff like that, but some of it is it's quite damp, isn't it? Ice crystals, you would say. If whatever hit Mars's moon, which left Phobos and Deimos, were to have hit it this way and caused that to collide into Mars, Mars would probably be more puffier than it appears to be today. Interesting. And another question I have, which is a strange one, rhetorical, but it's still one I like to think about, is if you collected all of those debris from the Kuiper Belt, Phobos and Deimos, and some of the shrapnel that's on Mars, and mosh this together, would that make a moon? And in comparison to Mars, what would that do to the internal core? If the internal core could be shoved back into the planet, would it cause it to become molten again in the stretching and squeezing? That would be interesting. But again, if you lose that moon all of a sudden, that gravitational pull, if it's going to be bulging the object towards it, lets go all of a sudden, that's going to create such a force. Mass was there, pulling one way, and then just like that, something smacks it, and then the mass is gone. What does that do to molten metal inside? Does it cause it to buckle? And then is that what caused the core of Mars to pop, causing Olympus Mons and fracturing the planet like it did? That's quite interesting. Yeah, interesting indeed. Yeah, so we look at one side of the moon. It's potted, but the dark side of the moon, I think, is extremely potted. Yeah, interesting. So with Earth, that's quite an interesting thing. So the first thought when I was speaking to my grandfather was to put it on the moon, but that would be like a sitting duck, wouldn't it? You've just taken atmosphere essentially and froze it. Water at the end of the day is atmosphere. If it's pressurized, you're making more atmosphere, which then causes liquid, and then after that it then crystallizes because it's too cold and then causes ice. So when the planet's in an ice age, if hit by a meteorite, that's when it's at its most vulnerable to lose it, because you've got concentrated pieces of atmosphere depending on what hits and where it breaks out. Not enough atmosphere to pull it back in. Anyway, so if you were to put the ice on the moon, that would be not good. But if you were to put it on the ice caps, take water and put it there, it's still risky, don't get me wrong, but it's going to take a longer time for it to melt that, and it could cause the ocean levels to drop down a bit, which then might stop erosion and different things like that. And also from the star, it could be shaded. That's pretty interesting. And I always wonder this too, that if you were somehow to refract the light closer to the core, equator, and do the same from the top and the bottom, let's just say if you could bend the light round, this would be blocking heat, but you would also be concentrating it to the center, the equator. Although this area would be frostbitten, and so would this, would that still be the same calculation, even if the light was hitting all of it? I know that there's different tilts and stuff like that. Let's just forget about that for a second. But if you block it out 50%, but increase the light ratio by 50% in a certain area, yes, that's going to heat this bit up, but it's also going to keep this bit cold. And aren't those calculations still going to be the same? The only time that calculation is different is if you were to grab light from this direction and bounce it into the planet, and take the light from this direction and bounce it into the planet, and then the natural light that hits the planet, you've just added extra light to the planet, or extra heat, extra radiation. So if this was to increase by 50% more light, which the planet would have to be over here to capture that, or it'd have to be the size of that in order to capture that, but you've found a way to refract the light off of a panel and hit it into there, and also heat. And you also do the same here, and you've added another 50% to the 100% that it usually receives, which is not really 100% because of the dark side. You've increased it by 200%. Then if you block a certain area, the fear of blocking it at the caps is that if you remove, I don't know, let's say 50% from the caps, so you make it totally dark, either cap, and it's 25%, 25%, rather than increasing it to 200 from here, you've decreased it by 50, so the light that gets and the heat that gets to the planet is only 50%, because you've minused it. So if you do block the sun at some area and you stop this level from reaching here, you're going to need something else to put that excess 50% in order to hold the balance. It's kind of confusing to explain it, to be honest. It is kind of a little bit. So the sun reaches light from here to here, let's say. That's, say, 100% for half the planet is bathed in light. Then we've got cloud cover, so that's another one, isn't it? So we could lower that a little bit. And then we've got whatever refracts off the planet from the snow also bounces light out. Does it bounce heat? Who knows? If you've got 100% here, and then you block it here, you've just decreased that number by, what, 10%? Let's say if you've liched out 10%. Yeah, sure, it seems like blocking it here is not going to do much. The closer to the star you are, the bigger the shadow. So that's interesting, isn't it? The smallest object that's more further away will cast the biggest shadow, which would cool the planet. The same if there was an ice age, you do it in reverse. So depending on what caused the ice age, for argument's sake, you can increase the light and heat by bouncing it from an area that's, let's say, over here. And this would orbit around the planet, and you can increase the heat. Via increasing the heat, if there is an ice age, you can then control an ice age. Seems like it's right barbaric, right? But again, the closer to the star you get, the more you're going to be giving. And then there's also light going off in this direction as well, but it doesn't hit the planet. And then there's some going in this direction and this direction, but it never hits the planet. But if you were able to grab this light and bounce it back into the planet, you're increasing more light. You're essentially expanding the planet's mass without actually expanding the planet's mass, because you're using the light that would have gone here. Now, if there was anything over here, this receives now 0, but now the planet is now receiving that, and you can heat it up and you can cool it down. But you have to maintain that overall balance. Where do you want to heat it up, as opposed to where do you want to cool it down? Give and take, I suppose. But if the planet has naturally heated up due to processes that have happened on the planet because humans or whatever else, and we've increased it by 10%, then decrease it by 10% over there. And then that keeps you back into the happy medium, the comfortable level that you're used to. Which is quite a strange thing to think about. And then depending on where that 10% is you've blocked it, it's going to hopefully get colder in that particular area. And if you've got water stored there, you've also lowered the ocean level too. which then slows down erosion. It's interesting, isn't it? Planets and stuff like that, and bouncing light and increasing light and decreasing light. Another way to look at this is figuring how to make the moon always lit. So we know the moon is going to orbit round, lovely, and it's going to meet the dark side. Let's say, for argument's sake, but let's say you wanted to utilize the moon to grow something on it. Right, interesting. Say, convert the whole thing into a greenhouse. Again, it's just possibility. Doesn't mean that it has to be done, but let's just think about it. So we have the moon, and then we have the Earth, and let's say we've got the sun, and again, the light can't reach the moon in this orbit. However, if there was something that orbited the Earth at the right ratio to capture the light from here and bounce it at the moon, and the same from here, and maybe the same from here, you can begin to light the moon. And what's more, you can light it in all directions, depending on what's then orbiting the moon. If any of that light is capturing a panel that's nearby, you can light the whole moon at any time without affecting the Earth, because Earth's still getting its usual dose of light, but now you're bouncing the light in order to put the light where you want it. Why would you want to do that? Maybe you're absorbing it because you want to grow food that's here. Who knows? Convert the Regorworth, melt those beads down with magnifying glass. Who knows? And then prop this up and you've got loads of domes over the already domes that you've got. Wonderful. This can be done. It has been done. This is easily done. And then you grow food on it. Then you can grow food all year round on it, just by changing the way the light is, because we often think that the star just hits here and here. We often think of it like a torch and that's it. No, it's going in multiple directions. If you were here, you're going to be bathed in the light. It goes in so many directions. And most of this is hitting the Earth from ratio here to ratio here. That light is hitting here. But this light over here is just traveling off into space anyway. But if you grab it, you can hit it at the moon, even on even when the Earth's shadowing it. I don't know. Who knows? If it's in complete shadow here, I dare say, would you even see it? And what's more, you can light the back. You can also use satellites in this way to bounce signals from anywhere in the solar system, using the same process, but don't think about it like light. Well, you do. You think about it like light. Imagine coding light with data and sending it back to Earth this way. Well, might get leached out in the sun, but still. Switch the process up and put this anywhere in the solar system, and you can bounce data anywhere. You can be in control of robotics, no matter where they are on the moon, no matter where they are on Europa. If it had a constant power source, I don't know, let's say nuclear power station within it that was shrunk down enough to do the job. Well, if you've got the data, you haven't got to wait until that comes into orbit. No, you can have this signal anytime you want. And there again, that speeds up the amount of data that you can get, because I'm not sure, if I think it is, it's in bursts, isn't it, when it lines up at certain times, and then when you've got the big ear lined up, and meh. This way, if you had multiple satellites that were around that were orbiting to look for places to land, mine, do whatever you need to do, at the same time, if these were dotted around in a strategy, no matter where that is around that particular area, you can always bounce the data back, and this could be looking at something else while bouncing the data from one to the other until it reaches back to the Earth. And then you've got a constant feed of data and lots of data coming in. The more data you have, you punch in to your mind, which is interesting, what you can do and how, and then you've got more thinking. How can we get that? Well, you know, for one person, it's a lot. It's not impossible, but it's overwhelming. But having loads of people do this and then plan ahead takes the load off, and then you've got more data coming in, and then it's punching into your reality more stuff that then gets you to throw more. It's like a bats use it as echoes, don't they? Where they screech, the signal goes out, and then it comes back and tells them how the world is. So it's a little bit similar. Humans do it in a different way. It's with data, information. You send the scouts out, whether being robotic or otherwise. That's the echo going one way. They look around with their instruments and then send that data echo back. And then again, you take that information that you wouldn't have usually have known, just be best guess, and then you can send that echo out again and get more data back, and you build from one to the other, from one to the other. That really gets the quantum and reality going, and you're combining quantum reality with quantum reality, and then well, the universe is your oyster, quite literally. Bite-sized steps. Again, future problems can be that if you overload the moon with extra mass, what does that mass do to the crust? That's the interesting thing. And the next thing is testing it to make sure that this light that you're bouncing on the moon isn't going to act like a solar sail and send the moon away. That would be an interesting thing. It's unlikely, but it's possible, I suppose. But if you start bringing mass back to the moon, what is that going to do to the Earth? So if it's true that it can cause an instability if you lose the moon, and again, it's just a theory, but again, it's something that is not to prevent you from going out into space, but it's something that you've got to look at, the balance. If that affects the core, what happens if you bring mass? So if to lose the mass, it could do something to the Earth. Maybe, maybe not. But if you bring mass, it could also work in reverse of that. What's it going to do to the Earth? So, and what, having two objects that orbit round? It's just pay attention to it. Any changes, although very subtle, the more you bring in, because the moon is a good platform, you haven't got much of an atmosphere to contend with, and anything you build on the moon is easier to get into orbit than it is on the Earth. It's really costly on the Earth, but it's not as costly on the moon. So it becomes a good working platform. And sure, if you can drill down, you can artificially create gravity. So it's an artificial gravity in the sense that it's good for digging. It's good for exploring. It's good for looking. XYZ. So it would be paying attention to what is being brought back. Yeah, essentially you could create a second moon. Or you could make one that orbits the moon. What does this do to the Earth? Pay attention. Just needs that careful observation, doesn't it? Anything untoward starts happening here. Is it this? And then it means not stop, it means limit. You can always take things off a moon in Europa and have it orbit around if needs be. Take things from Io, have it orbit around Io for a bit. And then once you've done something with this and it's scattered the mass, nice. Can you swap certain things from the Earth? You know, the stuff that you really, you know, it's abundant sand, isn't it? Can you take some sand off of here and put it over there? What does that do? Nothing? Something? It seems unlikely, but again, it's being careful with that balance. If Phobos and Deimos and the moon around Mars caused it to pop a spot in that way, then that would indicate that the lack of it caused a result. And therefore, to look at that action, there's a reaction. So if you add more weight, can that also do something? So that's another one you started talking with my grandfather about, is think of the Earth rotating. Nice. Wonderful. Now what happens if you pull something and put it over here? Does that knock its wobble? Or is that gonna... Maybe, maybe not. I often think about this because of Uranus. If it's on its back, why? Did something heavy land on it? Did something knock it over? Did something hit it very hard? Again, without that data, you can only speculate. Or was it just merely an imbalance? Something moved, froze quickly in that particular area and knocked it off of its axis. Well, not knocked it off its axis is probably the wrong thing. Changed its axis. Or is it reading a comet somewhere that's big and it doesn't want it? And the magnetism's trying to push something away. You just can't see it yet. Did something fly by? Did it brush past a galaxy too far and altered its balance? Yeah, these things are all things that are very strange to think about. But again, there's a question mark around Uranus. That's an oddball. And then how would Earth be if that happened to the Earth? That's the thing. And then learning that data can help you prevent that outcome happening. Interesting. There we are. So yeah, quite an interesting sort of bits and bobs there. Yeah, moving water. Is it possible? Yes. Bit by bit, cup by cup, ship by ship, whatever it may be. And then at least if it starts not working out too well or something else happens, well, you can bring the ice cubes back, can't you, and stick them around wherever it needs to be and let them melt back into the pot. We do it with drinks, don't we? Yeah. You can do the same on the Earth. Yeah. But yeah, the behavior of the Earth, without nature paving the way, and if we're too careless with it, we can lose it all. And then what? Can something happen because of that? Because we didn't see it before nature was about? So has nature becoming widespread affected the way the Earth is? And if we'd have came into awareness before nature, we would have seen the change, seen that nature would have started becoming widespread, and then we would have noticed some changes. So nature perfected the environment to balance for itself. Some good, some bad, depending on which way you look at it. Perhaps it's bad for ocean creatures and whatever else, and maybe it was good for them. And then it was good for land creatures. You know, shades of grey. So, yeah, and then ocean water seems to protect the ocean life more so, because if the land mass disappears, it's not a good day for humans or any land creature. But it does mean it's got something in the pipelines, which would be the next ones that want to come out of the ocean. And again, if you've got thin crusts and a tide, that's a wonderful thing. You notice it with orcas and certain dolphins, of when they come on the land for a bit and then they crash back into the ocean again. If they keep going with this, orcas will become land creatures. They get more and more able to, because the data that they're giving themselves is there's a different environment. Think of it as reverse free diving. It's an interesting thing, isn't it? So someone can go down and free dive, and bit by bit they get better and better at it. If they carried on through family generations, who knows where that could lead? It's not impossible. But orcas do the reverse of this, and they crash up on the landmass. And also salmon do the same when they jump out of the water. Evolution is learning in them, and it just takes the right evolving to happen with that information data which is being learned, and bit by bit they can become hardy to that, and over time you can see how very quickly salmon can get out of the water. Interesting. And also orcas. So again, they can come out of the water. That's interesting. It's dolphins that are very fascinating. That brain is incredible. And plus, with all of their capabilities, they have very good capabilities. Octopus as well. That's a fascinating thing as well. Certain octopus, they're learning the environment pretty well. And it only takes a little bit of time. And again, they can explore for large periods of time, and when the tide comes in, back in they go. So turtles, that's another one. You can see how things come from the ocean bit by bit. It doesn't have to, but... And then what could these life forms rise up to be? You know, if humans leave the planet and there are some remnants of life left on the planet, that's an if. You can see how after a few changes and different things happen, well, you never know. What do you reckon octopuses could evolve into? It would seem strange to see them be able to, you know, I think it's more humans would look more like octopuses in space, to be honest, but more cartilage-based life forms. Bones create a lot of problems. Not so many on the Earth, because it does break down eventually. But in space, that doesn't work very well. And again, learning this data with catacombs and decomposition and stuff like that, it's a very morbid thing to do, but it needs to be learned. Because if not, you can lose data. And if you think about it, just throwing things out of the spacecraft bit by bit, you're losing nutrients, and bit by bit, that's not good. Ideally, it needs to be recycling, and I trust the universe to sort that, you know? Whatever you want to call it, the divine, godly, light, whatever you want to label that, it will take care of that. Because it knows. That's the bit. And the body will transform to cater for that. Interesting. Yeah, very interesting. But if we believe that evolution can't go back and forwards, then we may never go back down to planets. That's the thing. Well, maybe you don't want to, and that's cool. And maybe you do, and that's also cool. And I think then evolution is like, aha, I remember this. It's not exactly the same, but you know. And again, if you were on the moon and you had children on the moon, and generation after generation that lived on the moon, they'd probably be able to dig it much more better than Earthlings going to the moon. They try and dig it and just wouldn't master it. The same dip if moonlings, if there were generations and generations of people living on the moon and generations of people living on Earth, if you swapped them, they would find it hard to dig the moonlings because they would have been tailored to deal with the moon by evolving. Would they grow different? Absolutely. Absolutely. And then if you have moonlings, marslings, earthlings, spacelings, these are going to be very different. After, if we were to go tomorrow, all of us decide, right, okay, right, we're going to Mars, we're going here, we're going there, we're going to go in space. These changes won't happen just like that. But after generation, if you could be resurrected for a point or create eternal life, you get to see these changes, which is very interesting, isn't it? Moonlings would look slightly different to Earthlings. Earthlings would look different to Marslings, and Spacelings would look different to everybody else. But yet, they're still humanity. Animals, that too will change and adapt. Some of it faster than others, some of it slower. Nature would change to adapt to that type of environment. And that's why there are so many different life forms on the planet. It's teaching you in order to be able to not be so judgmental about one another, because, you know, by and large, the environment is going to shape you anyway, and depending on which version you pick, you might want to pick to be little orbiters. It's going to look very different to someone that's on landmass, because they will have different requirements for that environment. Adaptations will obviously happen, and moonlings, they were going to adapt very differently after generation, and they are going to look very different to everybody else. Not any more beneficial and not any less. Just that these ones become preloaded to deal with that low gravity. Marslings, that would be a thing. The orange would bug people on Earth. And Earthlings going to Mars after the Marslings have evolved on Mars. The Marslings won't recognize the orange. The orange hue will seem like home, and sunset will seem mystical. And when they go to Earth, sunset will feel like home. Sunrise on certain days would feel like home, but the blue would piss them off. It'd be a lot to get over. Not really piss them off, but it would switch the patterning. It's very interesting, and people from Earth that are used to that blue would then go and really find it hard to get past the orange. But sunset, that would feel like home. And that's a very weird thing to think about. And people on the moon, if there were moonlings, would have no idea what you're going on about. They would see both the colors, but it would be the deep ink black. So night would then become homely, and day would become interesting, I would say. So, and the way the sun looks through an atmosphere might be very strange and hard to get used to. So yeah, you have very many different ways to see things in that. Could you imagine being able to see all of these things? You know, if you ever started cloning, that's when you would really get to put yourself in your own shoes as opposed to other people's shoes. That would be something. But then being able to clone would be a bit more perfected. That you could just pop out a clone that was suited for the moon. And you could pop out another clone that could be suited for the Earth, and another clone that could be suited, you know, that would be then developing cloning. You know, when you figure something out, you don't just stop at it. You'll keep going. Can I enhance this? I know I've got a clone that works here, works here, works here. Can I develop this a bit more to have it at a touch of a button and get inside a module? I think humans will do it in a different way and I think it comes naturally later on, depending on how long you've lived for, over generation adaptations and different things. That would be interesting. And then you would think, oh, what about all of that data? Are we going to be able to, well, this is when it gets interesting as well. What if moonlings and marslings, earthlings, Saturnians, whatever, you live on all of these bodies and you've adjusted and this, that, and the other, and then this part of the solar system has started winding down. It's coming to the end. The stars really beyond repair. It's time for us to all leave. Now we all have to leave these habitats behind, but have recreated these habitats. Can you imagine the space module with all of these differences in it? It'd be beautiful. Many different understandings and belief systems. Religions would grow in this. Mars, there would be different religions there. Space, it would create more religions. And then the Earth, origin, which would have the many different religions too. Each one is worthy because it's just a point of seeing something and the way to see it. Doesn't mean that one's better. Doesn't mean that one's worse. Just means there's another way to see it. When it's time to start leaving, well, then the evolving is going to happen, but it's going to be slightly different. They're going to evolve partly, and they're going to have cartilage and different things like that, but depends on how they evolved here. They might have already gone a different way, and that data's gone in a slightly different way to what someone that was left here and just stayed in space, opposed to Earth and, let's say, Mars. And then they're going to start to evolve and look similar, but still. But then when they begin to breed with one another, that's when the data sharing starts. But then when you breed with someone on the moon, well, you've got moon data. That's when cloning gets interesting, right? Because the data will be in you. Eventually, humanity would have, mixed quite a bit on the traveling to another star system. You've got plenty of time, plenty of resources. Then if you figure out cloning, do you notice how each time these variations are already in you just based on bloodlines, breeding habits, and then can you begin to clone in a way that is controlled cloning? It's the next level. Cloning, be revolutionary breakthrough and everything else, and it'll be absolutely wonderful. One way of surviving longer than death. It's not cheating it. It still is there, but less present if done right. Some may still pass on. It's not guaranteed, and then you would develop that to enhance that. And then the next one would be the people would carry on developing, and then it would be more enhanced cloning. So to be able to extract what part you need to be cloned as. Well, if you found another body like the moon and you already have this data in you, is there a way to enhancedly clone that so that you become already your clone is already pushed out as, and then there's got to be rapid Excel ratio on that as well. Again, nothing ever sits still long enough to stay as a snapshot, only the picture of the moment, that's it. Are you coming to land on me or are you going elsewhere? Yeah, it's getting early. I know I've not slept for a few days, so it's usually their time of the morning, so I'm probably going to wind this one down. But even still, to be able to enhance clone. I always go to my arm when I talk about cloning. Different body parts, I label different things in. Anyway, just help remember, link it to a part of the body. Cloning is here. But yeah, enhanced cloning, that's an interesting thing. To narrow it down and then rapid fire, and nothing ever sits still long enough. Because then you've got one breakthrough as it was like this, and then before you know it, someone else has took it a little bit further. And that's what we are as life forms in the nicest way possible. God, we don't half take the piss out of life, don't we? What we get, and we push it a little bit more further, and we push it a little bit more further, and we keep pushing it and pushing it and pushing it. You just notice that nothing sits still long enough. This phase has been a lot of sitting still, in a way, the same cycles. But that's only because reality has been programmed this way, hasn't it? We all do it. Life programs us in this way, and then we push the echo out. And when it gets to this stage, you'll understand that the bounds are the echo. Then it wants to be moving more faster and faster and faster. Why? Because people want to live. Try and find that envelope, and then depending on how many generations that you've got in yourself, is all the information for your ancestors already inside you. Universe created you once, that's for sure. But when you then begin to narrow down cloning, when you begin on that, narrowing it down and enhancing it, making it specific, can you find your ancestors in it? And rather than an external force resurrecting you, begin to resurrect via cloning your bloodline, your lineage. But again, that's an interesting thing. I believe it's absolutely possible, as long as you've got the remnants, which you are the living remnants. And all of that data is there. It compacts this way in order to come together to create your life. And providing your bloodlines are still living. And sometimes you might need the variations, the ones that went off and cheated here and there. Those might have important pieces of information that may help bring you back one day. That's an interesting thing. And then how would you guarantee the future that if they figured that out, that they would honor that? You see, that would have to be a selfless humanity to do that, wouldn't it? But the belief of selflessness has to come sooner so that it prepares you to come back later on. Because if they're selfish, they might not want to do that. But if they're selfless, do you see how this can change the dynamic that already automatically is already pre-coding into that? Again, it's up to you what you believe. It might sound science fiction, but it's got to start somewhere, hasn't it? Well, one of us has got to go out and take the crazy straw, or train, or boat, or planet, or universe. It's got to start somewhere. And I'll get that egg on my face, I don't mind. Reality is far stranger. And aren't we inferior to that? Anything you can think of and you think it's crazy, I can assure you the universe is like, want to bet? Do you want to bet? That sounds crazy. That sounds possible. You put the word I'm in possible. Yeah. Anyway, but cloning. Yeah, I often puzzle on cloning. Well, I don't sleep anyway, so I enjoy thinking. Yeah, it's very interesting. Anyway, but now I'll release a bit more about this cloning process a little bit later on, so yeah, I'll just do it bit at a time, bit at a time. But I've really run away with that concept, and it's already happening. This already happens here on this planet right now as we speak, so it's only a matter of time. And another thing, if you were to say that people were going to create solar panels, which I look at as leaves of a plant, technically as a solar panel, it's creating energy, which allows the plant to grow. And solar panels remind me of plant leaves, hence the solar tree. Strange thing. So you've already backward engineered a leaf, technically, to give energy. Well, that's a very strange way to think about it. So one concept of plants is already mastered, which is a solar panel. That's a weird thing. And plants can clone, so you're already on the right lines. And then bit by bit, you'll begin to figure it because you already figured out solar panels. That's the... You know, if you were to go back in time and say that there was... you can capture this energy from the sun, a bit like a leaf, people would call you crazy. But it's been done, and then to look at plants that clone, that's interesting. And it's nigh on impossible to tell how old a plant is that's been cloning. Nigh on impossible. Even if you were to carbon date it, you'd need the original. And then depending on how old that one made it versus the next, it becomes nigh on impossible to work out how old that plant actually is. It's almost like the original didn't exist, and where you come into it in your awareness, oh, it's this plant. But if you don't know how long it's been cloning for, how do you age that specimen? It's almost like the first one that started the cloning journey didn't exist because it died off. But it does exist because it's still here. That helps me understand that having two Earths, one here, one over there, and then that makes you look at the universe in another way. If it's already doing it here in front of you, can it do this with anything else? Can it do this with the whole Earth? Can it do this with the whole solar system? Can it do this with the whole universe? These are quality questions that you need to sit down with, and it sounds crazy when you first dive into it, but then when you unpack it in the patterns and everything else, it then looks, wow, this is highly feasible. How do you age that plant when the original is not here and it's done nothing but clone? So I can age you. If I take a look at you, I can age you. But I know there's extra X amount of 50 years worth of cloning on that, and you're not reading 50 years. That's the interesting thing. Whoosh. And that doesn't exist, so that's caused me to miss a part of the picture, and it was almost like that didn't exist, but then it must have done for you to exist, and you've gone a different way of the channel. You're not able to reproduce in one way, so now you clone. Humans made leaves, solar panels. Keep copying that process. It won't be long before you clone, and then asks you another question. And if you've been made here once, can the universe make you there again and in multiple versions of you? Wow, that's interesting, isn't it? And even though your ancestors walk with you in your DNA, that's interesting, isn't it? Wow. Can you extract them from it? And then that becomes a Pandora's box. You've got all the puzzle pieces, but it started like that and came this way and reached to a point of now. In cloning, you would have to go the opposite way. Wow, mind-blowing. Wow, and that is definitely possible because it was possible that it went this way, and it's possible that it can go the other way. Oof. Wow, it gets deeper, I must admit. Anyway, I'm going to leave it there. I'd love to go on more, but my legs are absolutely cramping up right now, so I got to move, and yeah, I'm going to leave myself with my thoughts. That's interesting. I'm going to go inwards. Yeah, good. Anyway, it's been fun.